Today, let us discuss on the topic importance and recent advances in post-harvest technology of horticultural crops. Horticulture plays a significant role in Indian agriculture. It contributes 30% in GDP from only 11.73% of India's arable land area. India is the second largest producer of both fruits and vegetables in the world. 52.85 mt in fruits production and 108.20 mt in vegetables production. However, this abundance of production is not fully utilized, and a considerable amount of fruits and vegetables produced in India is lost due to improper post-harvest operations. As a result, there is a considerable gap between the gross production and net availability. Though India has attained the second highest position after China in producing vegetables and fruits in the world, the post-harvest losses touched an alarming amount of rupees 2.50 crore in 2013-14. The research team engaged by ASSOCHAM found that 30% of fruits and vegetables were rendered unfit for consumption due to spoilage after harvesting, virtually negligent attitude towards post-harvest losses, and absence of food processing units and unavailability of modern cold storages. Now let us discuss the regions of post-harvest loss. Most fruits and vegetables are seasonal crop and perishable in nature, and because of their high moisture content and are inherent more liable to deterioration, especially under tropical conditions. Moreover, they are biologically active even after harvest and carry out transpiration, respiration, ripening, and other biochemical activities, which leads to deterioration of quality of produce and finally makes it unmarketable. In a good season, there may be a local glut, particularly of fruits, but because of inadequate transport facilities, good roads, and poor availability of packaging material, the surplus cannot be taken quickly enough to the markets in urban areas, leading to heavy wastage. Similarly, some of the fruits of some places are totally unknown in other places because it is neither grown nor reaches that market. For example, the northeastern part of India has numerous indigenous fruits and vegetables which are not only very rich nutritionally but also known to have therapeutic values. The fruit and vegetable surplus cannot be often stored for sale in the off-season because of inadequate local cold storage facilities. Now let's see the magnitude of post-harvest loss. Post-harvest loss is observed in the field after harvest, in grading and packing areas, in storage, during transportation, and in the wholesale and retail markets. According to Chadha 2009, India loses about 35 to 45% of the harvested fruits and vegetables during handling, storage, transportation, etc., leading to the loss of rupees 40,000 crores per year. The study titled Horticulture Sector in India State-Level Experience also highlighted that about 22% of fruits and vegetables produced in India reach the wholesale market. Among the states, post-harvest losses are maximum in West Bengal, worth over rupees 13,657 crore, followed by Gujarat rupees 11,400 crore, Bihar rupees 10,700 crore, and Uttar Pradesh rupees 10,300 crore. The sites of post-harvest losses. Important sites for post-harvest losses in India are farmers' field 15 to 20%, packaging 15%, transportation 30 to 40%, and marketing 30 to 40%. The recent advances in post-harvest technology. Many advances have taken place in processing and post-harvest handling of fruits and vegetables. Some of the advances in the technology have been discussed here. Harvesting technologies. A large number of manual and mechanical harvesting techniques have been developed to minimize the injury caused to the fruits during harvesting. Dapoli harvester, tractor-mounted ladders, which place the pluckers at right plucking position, tree suckers with nets at the ground level, harvesting by using chemicals, etc. are new technologies presently used worldwide. Next is the pack house concept. The harvested horticultural commodities are to be brought to the packed house immediately. In the reception, the commodities are dumped in water to minimize injury, or they are floated in the channels to the washing unit where they are washed using chlorinated water. A series of rotating brushes remove dirt without causing injury to the fruits. At harvest, the horticultural commodities accumulate a lot of field heat, especially during summer. In order to remove the field heat, the commodities are subjected to cool temperature. This is necessary so as to reduce the various physiological activities like respiration, transpiration, enzyme activities, etc. This also helps in reducing the load on refrigeration system during transportation in a refrigerated van. There are various methods of pre-cooling like icing, air cooling, forced air cooling, hydro-cooling, vacuum cooling, etc. Minimal processing of fruits and vegetables. There is heavy demand for fruits and vegetables which have natural look, easy to cook, or ready to eat types. It includes operations like washing, sorting, trimming, cutting, slicing without affecting the freshness of the produce, and nutritional quality with extended shelf life and acceptable to the consumers. Customers also prefer ready-to-eat fruits rather than to have the cumbersome practice of removing the skin of the fruit, removing the bulbs and eating them. Physiological and microbiological activities are the major challenges that come in the way of the minimally processed fruits and vegetables. The tissue must remain alive and maintain quality with reasonable storage life. Various physical and chemical mechanisms like lowering temperature, changing gas composition, increasing relative humidity, edible coatings, osmotic membrane coatings, chlorination, high hydrostatic pressure, oscillating magnetic field, high intensity pulse electric fields, osmotic heating, intense light pulses, irradiation, biopreservatives, hurdle technologies are used for enhancing shelf life of minimally processed fruits and vegetables. Next, let's come to the aseptic processing. Presently, the most popular technology is the aseptic processing, which preserves food by sterilizing the product and containers separately. This is in contrast to conventional processing, where the product and the container are sterilized together. Here, food product is sterilized continuously through a heat exchanger and filling the product in an aseptic filler. Next is the edible coating. Edible coating is widely used for controlling minimally processed products from deterioration. Generally, three groups of materials like protein, polysaccharides, and lipids, including waxes, emulsifiers, and their derivative, are used for the purpose. Next is the osmotic membrane coating. Here, pieces of fruits are coated with an edible film produced by limited osmotic dehydration. This helps in maintaining products' soft texture and fresh character. Next is the membrane technology. The membrane technology is widely used for separation of materials across a semi-permeable membrane by forcing some of the molecules in the system through the membrane while retaining others. Next is the biopreservatives. There has been a lot of negative feeling in the use of chemical preservatives in processing industry. Hence, emphasis has been laid on use of natural antimicrobial agents or biopreservatives in processing industries. Some of examples of biocides are lactic acid, niacin, netamycin, tetracycline, subtilene, etc. Next is the hurdle technology. Of late, the most widely used technology in processing industry is the hurdle technology. Consumer prefers nutritious food that undergoes the minimum processing. In hurdle technology, the food is subjected to several barriers or hurdles of mild nature so that one gets safe as well as nutritious food. The hurdles generally used are lower temperature, chemical additives, mild heat treatment, modification of pH, modification of water activity, and suitable packaging, etc. Next is packaging by flexible films. The most drastic advances that have taken place in post-harvest handling are in packaging sector. Nowadays, one can package any food in one corner of the world and send to the other corner without much loss in its quality. Flexible films are one that is not rigid and less than 0.25 mm thick. They are heat sealable, suitable for printing, and add little weight to the product, suitable for high-speed filling. The flexible films are made up of single-film polymer, cellulose, polyethylene, low-density polyethylene, LLDPE, HDPE, etc. For packaging and preservation of cooked food, cling film are most commonly used by airlines, fast food stores, or for storage of food in refrigerators. Shrink wrapping consists of use of thermoplastic films having the property of shrinking with the application of heat and is used for pallet shrink wrap, frozen food, and bagged products. Retortable pouches. Retortable pouches are those packaging material that are used for packaging thermally processed fruits and vegetables. It is made of 3-ply laminate consisting of polyester film laminated to aluminum foil and polypropylene film. Retortable pouches can tolerate high degree of temperature. The food inside the pouches can be heated before taking. Next is the co-extruded films. Co-extruded films consist of simultaneous extrusion of 2 or more layers of different polymers. Co-extruded films have high barrier properties, thinner than the laminates. A 3-layer co-extrusion has an outer presentation layer having high gloss and printability, a middle layer providing stiffness and strength, and split resistance, and an inner layer suitable for heat sealing. Rigid and semi-rigid containers. Rigid and semi-rigid containers like trays, bottles, and jars are made from single or co-extruded polymers. They are corrosion resistant, low cost, unbreakable, easy to seal, and lower weight can be molded into convenient shapes. However, they are not reusable, have a lower heat resistance, and less rigid. Next is cold chain management. Most of the fruits and vegetables get spoiled due to exposure to high temperature. In the modern cold chain system, right from the harvesting till it reaches the consumer, the commodity is maintained at a lower temperature. In the conclusion of the topic, post-harvest loss of fruits and vegetables are enormous in our country. However, this loss of fruits and vegetables can be minimized if not completely eradicated. A 10% prevention of the loss shall mean a huge amount of monetary benefit. It would have positive impact on the price of the horticultural commodities and shall be easy reach of the poor people. For this, there is need for proper infrastructure development like cold storage facilities, transport facilities with modern cold chain system, good roadways, marketing facilities, etc. In recent years, it could be seen that a lot of progress has been made in the post-harvest and processing sector. The advances in this sector have made it possible to process almost all kinds of fruits and vegetables and in transporting them to any corner of the world. It is a very fast-growing sector and a lot of progress in the sector is foreseen.